quadratic. So here's another example. So let's find the A, the B, and the C for this particular function. What's my A? What's my A?
1.
What's my B?
-3.
And what's my C?
1.
Awesome. So is this going to be concave up or concave down? Up. Because the A is positive, so it's concave up. Is that a smile or frown? Smile. What's my y-intercept?
1.
I can go ahead and graph that. I'll put my y-intercept on there. Axis of symmetry. That's my line. X equals a number. Negative b over 2a is the number it's going to be. X equals negative b over 2a. So negative b is -3, so we're careful with those negatives. 2 times 1. So -3 is 3. 2 times 1 is 2. My axis of symmetry is x equals 3 over 2, which is 1.5, 1.5. So I'm going to estimate where that is. Here's 0.1, here's 0.2. So right in between x equals 1 and 2, I put in my axis of symmetry line, x equals 3/2. Then I want to find the vertex. The vertex is always on the axis of symmetry, so my x is 3/2. Yeah?
You could put the other 3-point down.
Oh, yes, I can. Thank you for reminding me. This axis of symmetry is my fold line. So if I do have a point that's 1.5 away to the left, I'm going to have another point that's 1.5 away to the right. Thank you for reminding me. So I get my point for free. I might as well put it in there. All right, so that vertex, this is concave up. So it's something like this. We don't know exactly where, but let's see what we get if I use my calculator to plug it in. Because this one's a little bit harder because of the fraction. So x squared, so my x is 3/2. So I type that in and I square it. Minus 3 times that 3 divided by 2 plus 1. And I get -1.25, which I can put right here if I want to. I can put -1.25. That's helpful for graphing. However, I don't know. I see a fraction. I kind of want a fraction. So I'll just turn that number into a fraction by pressing the math button and option 1. And I get -5 over 4. So now fractions match. So I'm going to graph that. So I go to the left 3/2, and -5/4 is just a little bit smaller than that -1. Okay, so let's look at what we have so far. Can we kind of imagine, if in our mind we kind of complete this, what's going on here? How many zeros is this one going to have? How many zeros? How many? 2. Because we can kind of see, as we draw this, it's going to cross right there. It's going to cross right there. So I know there are 2 zeros. So let's see if we can find them. So I take my function, x squared minus 3x plus 1, and I set it equal to 0. That's how you find the zeros of the function. And so our method is factor this and set each factor equal to 0. So let's go ahead and factor it. It looks like it's times 3. So there's my x times x. I need 2 numbers, multiply to 1, but add to -3. What? 2 and negative? Well, if I put a 2 here, if I multiply, I'm not going to get a 1. Now, I heard something over there. What'd you say? It's not possible. Let's see. The factors of 1 are 1 and 1. That's all I got. So, since this is positive and this is negative, that means I would have to put a -1 and a -1, and they don't add up. It's not working. I didn't know it was allowed not to work. Well, the sad truth is most of the time, it really doesn't work. If you're doing like a real life example, it almost never works. Sadly. Well, sometimes it does. So I don't know what this is. Right? Uh-oh. We can't seem to factor it. So how are we going to find the zeros? Now this question, does it even have zeros? It sure does. We can see that there are going to be 2 zeros just by looking at the graph. So I wish there was another way to do this. I wish there was another way to solve this particular equation. Guess what? There is 2 more ways. We're going to look at 2 other ways. Today we're just going to look at this first way. And this will leave for fun for another day. The quadratic formula. What, you might ask, is the quadratic formula? You ready? Okay, it is just x equals, right? You solve the equation, x equals plus or minus the square root of b squared minus 4ac all over 2a.
Yeah, simple as that.
Got it?
Simple.
You got it? You ready for the test? Who can repeat it already? As I hide it.
Negative b.
Negative b plus
Nothing
x
to
squared
say.
minus
Something
4ab.
All right, stop right there. Stop right there.
She's got it.
Yeah,
Stop right there. I have the foolproof way that I'm going to show you in a moment how to do it. But first, I want to kind of apply it. I want to show you how it works. So, right where we've got this function, that's what we were working on, and we want to know when it equals 0. So you still set up your equation. I still want to know when this equation equals 0. But what is this guy trying to tell me? You can find the x by plugging it in and making substitutions. What's the a and the b and the c? It's the same thing we've been using all along. Right, I've got a little space from here. I guess I should put them down here. Right, the same a, b, and c from ax squared plus bx plus c. Only now I've got something a little more complicated to plug it into. So negative 3, because that's negative b, plus or minus square root of b squared. Now be careful, b is in parentheses. That whole quantity b squared minus 4 times a times c, all over 2 times a. Right? It's a lot of substituting. Do you have to be careful? Oh, yeah. Let's see if we can simplify a bit. What's a negative negative? Plus or minus square root of negative 3 times negative 3. 4 times 1 times 1 over 2. 3 plus or minus square root of 5 over 2. So, this is, how many zeros were there for this one? We looked on the graph. How many are there supposed to be? 2. This is actually 2 numbers. You know what the 2 numbers are? 3 plus the square root of 5 over 2, and 3 minus the square root of 5 over 2. That's what plus or minus means. It means you have the plus of this thing, and you have the minus. So these are the zeros. These are the exact values. Now, I don't know about you, but if somebody said, sure, go ahead and plot 3 plus square root of 5 over 2, I probably wouldn't know what to plot. Does anybody here kind of have an intuitive sense of what that is? You do?
Oh, no.
Oh, I don't. So what you do is you take your calculator and you say, well, this is the exact value. This is an irrational number here. So this whole number is irrational. Let's get an estimate by typing it into the calculator. Here's how you do it. Now do it with me, because if you don't do this correctly, it's going to be wrong. There's a couple of options. Here's what I do. I type in 3 plus the square root of 5. I just type in the numerator. Square roots over, it's the second key by the x squared. And then you press enter. Now divide by the denominator. Divide by 2. If you do that all in one line and no special parentheses, no special grouping, it's going to do the wrong order of operations. If you want to do it in one line, you have to put this part, the numerator, in parentheses first. So I usually just do the numerator, hit enter, divide by the denominator. 2.62. So this one's approximately 2.62. Let's see what 3 minus square root 5 divided by 2 is. That one. Again, I hit enter after I typed in my numerator. Then I divide it by 2. And it's approximately 0.38. So 2.62 and 0.38. Let me go back to our graph. So 2.62, where's that? That's 1, that's about here. And 0.38, that's about here. Do they look like the right zeros? They do. So it just so happens for this one, the zeros were irrational numbers, which is why I couldn't factor it. And you know what? This happens a lot. Most of the time, this is what's going to happen. So we're going to use this quadratic formula as a way around it. Now you can use the quadratic formula anytime. Not only when you have kind of weird looking ones, but normal ones as well. So I'm going to do one like this one here. This is on the U-tries. This is A on the U-try. Let's just try the quadratic formula again. A equals 1, B equals negative 6, C equals 5. Now we can actually solve the equation x minus 6x plus 5 equals 0 by factoring. This one does factor. Let's try it with the quadratic formula. So negative b plus or minus square root of b squared. B is negative 6 squared minus 4 times a times c root all this thing over 2 times a. Now I'm writing quickly. I've been doing this for 100 years. You're going to have to be really careful with these substitutions. It's tough stuff.
Do you have to remember this?
Yeah, sure, of course you do. And I'm going to show you how just for a moment. I just want to apply it first before we go over how to remember it. Okay, so negative 6 is a 6 plus or minus square root of, let's see, what's negative 6? That quantity squared? Positive 36 minus 4 times 1 times 5. 20, right? All over 2 times what? Alrighty, wait a second. 6 plus or minus square root of what's 36 minus 20?
16.
Over 2. Oh, wait a second. Square root of 16. 4. I can do that. That's 6 plus or minus 4. Over 2. Yes, you do. Now, these are two numbers. What's 6 minus 4? 6 minus 4 is 2 over 2. 1. 6 plus 4 is 10 over 2. 5. There it is. So now we could have done this with factoring. When it's easy to factor, why not? X and X. I need two numbers multiply to 5 that add to negative 6, right? So we can get it that way. But anybody have a little trouble factoring and maybe it wasn't their favorite? Oh, only one person said yes.
Factoring is way easier.
Well, if it's easy to factor, but sometimes you can't, and sometimes you forget. The quadratic formula is a way to solve that equation without having to factor. Type 5 sometimes are tricky. You can use the quadratic formula. Question?
Would you be able to simplify that fraction 6 plus or minus 4 over 2 seems like 3 plus or minus
3, yes. Does it work? 5? Yep. You absolutely can.
2?
Yeah.
How did you get 1 and 5 again?
I broke this apart. I said this is the same as 6 minus 4 over 2, and it's the same as 6 plus 4 over 2. Is that right?
Yeah.
So then I said, well, that's 6 minus 4 is 2, over 2 is 1. 6 plus 4 is 10 over 2, right? I went a little fast with it. Okay, so that's the general idea. Now, this is good to know, but it's a lot to remember. I have a foolproof way of doing it. I will say this, when I taught geometry, we need it again in geometry, you're going to need it again in algebra 2, you're going to need it again in calculus. You need this. Very few students remember it, except for Mrs. Grieser students. So I'm going to show you how. I'm going to shut this off for a moment.
I'm not sure this even time. Oh God.
Okay, so we are going to now show how we can do this. 1,